examples for your Delta Math practice for tomorrow. If you have something like these two numbers in the problem, it's going to be one of these three things right here. Okay, so if the inside number is bigger, like the 5 is bigger than the 3, it's going to not just dent in, it'll loop in. So it's going to have an inner loop. So I'm going to pick this one. And since it has the word cosine, we know cosine's x over r, so it's going to be more on the x-axis, either like this or like this. Since the coefficient of cosine is negative, I expect it more to be pointed to the left, like a negative x, but we can also check it. The way we can check it is we can actually fill in a point and see. Like for instance, if I come to theta, and instead I fill in pi, just for example, so I'm filling in pi, and so that means that I am pointing this way. So like it means I'm swinging around and pointing towards pi. So let me put this right here. All right, so you're in the circle and you're swinging around like this, and now you're pointing this direction, and you're going to find out how far to go because my angle is theta is pi, so I'm pointing right here. And if I fill in pi, I get 3 minus cosine of pi is -1, so I'll get 5 times -1. So if I add that up, I'll get 8 total. So what does that mean when I fill in pi and I get 8? Okay, so that means that I have, sorry, trying to get my arrow. Yeah, so that means I have started here, rotated pi, and I'm now, look at my arrow, I'm now pointing in that direction, and I see how far to walk. I'm going to walk out 1, 2, 3, 4, 5, 6, 7, 8 units in that direction toward pi. So let's do that. So I'm going to come 1, 2, 3, 4, 5, 6, 7, 8, and then this inside number is going to be 3 minus 5, so it's going to back up to 2. Okay, let's see if that's centered or locked on good. All right, let's do the next one. All right, so these are easy, just a radius of 2. That's a circle that is centered right at the origin. It's as easy as it could be. It has no theta. That means every theta is going to go out 2. So no matter where you turn, you're going out 2 units. So I get r is 2, and be glad if you get some of those. And let's go to the next one. All right, this doesn't have a plus in it, so it will not be one of, or a minus. It will not be one of these. It will not be one of these. It'll just be a circle. All right, now this gives us the diameter. It's a cosine. That means it's going to be heavy on the x-axis, and it's a positive cosine. So I'm going to pick a circle, and I'm going to move this over here, and I'm going to make it have a diameter of 3. So you got to be careful. I got to shrink this down, and you got to be kind of careful to make it land with a diameter of 3. That might be close enough for Desmo to check, Delta Math to take it. Okay, next problem. All right, now you see I have these pluses and minuses. This one's going to be heavy on the x-axis. I expect it to be pointing in the positive direction because of this. And the furthest it can go is 6 and 0. When these numbers match up like this, it's going to be a cardioid. It won't loop in, it'll just dent in. I've got to swing it around to where it's positive. You can check a number, like if you put in 0. So I'm going to point this way. So I'm pointing this way, and I'm going to say -3 plus 3 cosine 0. I always fill in something kind of convenient. cosine of 0 radians. Cosine of 0 is 1. So since this is 1, I get negative 3 plus 3, which is 0. So that means I turn this way and I don't go anywhere, like this. So I turn this way and I'm pointing towards 0, like this, and I just stay right here. So I'm centered there. Now I'm going to put in pi and watch what happens. If I put in pi, I guess I'll work on this one. So right now we have negative 3 plus 3 cosine pi. I like to put in, sorry, it's not, let me grab it. There. All right, the cosine of pi is negative 1. So you'll get negative 3 and negative 3, so you'll get negative 6. So what does that mean? That means now you're pointing over here and you're facing this way. But you get negative 6 from this. So that means I'm pointing this way, but instead of going forward, I move back 6 this way. So here I'm going to go back 1, 2, 3, 4, 5, 6. So I get 0 here and 6 here. Okay. So if the numbers are the same, like this, you get a cardioid. All right, so now these numbers are not the same, and since the inside number's bigger, it will dent in like this, the lemma sign. Sine is like y, so it's going to go up. Now it's going to go up at pi over 2. The sine of pi over 2 is 1. So when I turn pi over 2 this way, when I'm facing this way, when I turn pi over 2 and I'm facing this way, it'll tell me whether to go toward it or away from it. So here, I'm faced toward pi over 2, and when I fill that in, I get 7. So 1, 2, 3, 4, 5, 6, 7. And then the inside's going to be 2 minus 5, which is 3. So this dents in 3 units. So look at your numbers, and the highest it can go away from you is 7, and then it can also dent in 3. 2 plus 5 and 2 minus 5. All right, so here we notice that it's not going to be a heart, or the numbers would be the same. This number's not bigger, so it won't be this one, and it won't be this one. So that means it's going to be this one. Now play around with it. Negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. I see the word sine, so I'm going to be on the y-axis, okay? So it's not going to dent in, it'll be kind of flattened out. And it's sine, so I'm going to be on the y-axis. Think of yourself pointed toward pi over 2. If you point toward pi over 2, that would end up giving you 2 times 1. Negative 3 plus 2 is negative 1. So I'm pointing to pi over 2, but I go back 1. So it's kind of in the right place. So I was pointing pi over 2, but I had to go backwards. Now let's go to 3 pi over 2, which is a good thing to do with sine. 3 pi over 2 is negative 1, so I get a negative 5. Now if I rotate around and point 3 pi over 2, so if I swing around and point 3 pi over 2, and let's review what we got. When I filled in 3 pi over 2, I got negative 5. So you're pointing this way, but you're told to go backwards, not toward it. So you're going to go up here 1, 2, 3, 4, 5. So you're pointing this way, but you've got to walk backwards. So this is 1, 2, 3, 4, 5. So it's not quite a cardioid because it doesn't come into 0, 0. All right, let's see what we got. All right, now these numbers are different. This is going to be cosine. It's going to poke in. I'm expecting it to be over here probably, but we can test it. All right, with cosines, I like to fill in pi and 0 on these. If you fill in 0, you'll get negative 8. Cosine of 0 is 1, so you'll get negative 3 minus 5 times 1. You'll get negative 8. So you're pointing towards 0, and you walk backwards 8. And then if the inside number is negative 3 plus 5, if you filled in pi, and you would get 2. So that means you go toward this 2. The inside part's 2, the outside part is 8. I think it's locked on good enough. All right, theta equals pi over 6. That means it doesn't care what r is. Your angle has to be pi over 6, which I think is this one right here. Because this is 90, and this would be 30, that would be 60. Each one of these is 15 degrees. 15, 30, 45, 60, 75, 90. So this is pi over 6 right here. So it's going to be a line, and it's going to be all the points at pi over 6. So it'll be a line. All right. So theta equals our lines, r equals our circles. All right, notice this one doesn't have any plus or minus in it, and it's got this extra. If that 5 wasn't there, this would just be a circle, a negative circle on the x-axis. But with this 5 in there, I'm going to have one of these roses that looks like a daisy. When it's odd, you have 5 petals. If it's even, you have twice the petals. So now we have to decide how big the petals are and where they're twisted. So I'm going to see where this is and see where to twist it. Now, how in the world am I going to figure that out? What you're going to do is, a good idea to do this is to take the period of cosine, which is 2 pi, and divide it by 5 units. So you have 2 pi divided by 5. Another way to do it also is to try to fill in some numbers where you get something. Now here's a clue. Cosine, usually the first petal, one of the first petals, the one you can drag, usually rest on the x-axis. And the sine ones are usually tilted some. So let's try this rested on the x-axis, and we're going to go out 2. But I have to be careful because it says negative 2. So this is a lot more to think about. But the petals are going to be too long. All right, let's just check pi. Negative 2 cosine 5 pi. So I have negative 2 cosine 5 theta, and I'm going to put in pi. Oh, I meant to put in 0. I'm going to put in 0 first. All right, so the cosine of 0 is 1. So you'll be pointing towards 0 and go back 2. So I'm pointing towards 0, but I'm going to have to go back 2. And that should be it. You could find a few more points if you wanted to, but let's check it. So it's good just to fill in a sample point. All right, this is going to be a line at pi over 4. So get it right there at 45. This is going to be a cardioid going up. Numbers are the same. It's going to go 3 plus 3, 6, 3 minus 3, 0. Since it's all positive, I would expect it to be up here. I think this is 6, and the other one is poked in right at 0. Okay, now we got a radius of negative 2. I know that seems weird. You usually don't think you could have a radius of negative 2, but it just means the direction that you're going to go in. Like it might start over here technically, but you have a radius of 2. In polar, you can have the negative. This is a line. Well, you got to figure out where 5 pi over 4 is, which would be over here. This one's, the number's not bigger right here, so it's going to be one of these. See sign? That means it's going to go on the y-axis, and it's going to, the highest it can reach is 5. So I'm going to be on 1, 2, 3, 4, 5. And then the inside part is going to be 3 plus 2 is 5. That's the longest. And then because sign can alternate between 1 and negative 1, that's going to be 3 minus 2, which is 1. Now what do I mean by that? If I fill in pi over 2, check it out, you'll get 3 plus 2 times 1, you'll get 5. So you turn towards pi over 2 and you go 5. Now fill in 3 pi over 2. So you're pointing at 3 pi over 2 this way, and you get 1. It just tells you to march forward 1. It doesn't dent into 0. So you're really making a play with this. 3 plus 2 is 5 going up the y-axis. And then going the other way, 3 minus 2 is just comes out 1. Okay, this one's going to be similar. So I'm going to pick this one. And it's going to be 4 plus 2, which is 6. 2, 3, 4, 5, 6. And then 4 minus 2, which is 2. So this one's going to come this way. All right, so let's keep practicing. All right, this one is going to be a flower, a rose. The petals will be 3 units long. Cosines, oh, and we have 5 petals. Since it's negative, I expect it to be over here. 1, 2, 3, 4. I think that, did I go too far? 1, 2, oh wait, there's 3. 1, 2, 3. And once you get this one anchored, like for instance, if you fill in 0 right here. 5 times 0 is 0. The cosine of 0 is 1. You get negative 3. So you're pointing towards 0, but it tells you to go back 1, 2, 3. Can I keep practicing? Okay. Okay, now here's a flower. I'm glad we came on this one. It's got 5 petals, and since it's sign, it won't be laying on the x-axis. So one of the petals is going to be laying probably on the y-axis. Let's fill in pi over 2. Pi over 2, be careful, 5 pi over 2 is this way. This is pi over 2, 3 pi over 2. This is 5 pi over 2 is pointing this way. The sign of pi over 2 is 1, but I multiply it by negative 5. So I'm pointing this way, but I go down 5. 1, 2, 3, 4, 5. And that should be it right there. All right, so the petals are 5 units long, and I should have 5 of them. And the main one right here, the first one's pointing downward. All right, this is the line at pi over, this one happens to be one we've had before, 5 pi over 4. All right, this one is where the inside number is less, so it's this one. If the numbers are the same, it's this one. If the inside number is bigger, it's this one. So now I have this one, and it's going to be on the y-axis. So I get my little circle thing on the y-axis, and then you can fill in pi over 2. When you do that, if you fill in pi over 2, you'll get a total value of negative 1. So I'm turned toward pi over 2, and I've gone negative 1. It's right here. So I turned toward pi over 2, and I went back 1. You can fill in 3 pi over 2. It'll tell you to go pointing this way. It'll tell you to back up 1, 2, 3, 4, 5. All right, that's going to be similar. So I'll do that one really fast. If I fill in 0, I get negative 7. So that means I'm pointing this way, but I go backwards. Sends me, instead of toward it, I've got to go backwards. 1, 2, 3, 4, 5, 6, 7. And then when I fill in pi, which is -1, it'll make it go -1. So now I'm pointing this way, but I go back 1. So that should be it. Let's see what else we have. That's a line. 11 pi over 6. That's a line. Pi over 4. That's a circle. Notice there's only one thing here, but it won't be a circle at the origin. It'll be a circle on the y-axis with the diameter of -2. So let's pick a circle. I'm going to move it down and get a diameter of -2. So that's a little harder to do on these. Okay, so that should be it. That'll be a flower. As soon as that's got more to it, it'll be a flower. And if it's even, it has twice the number of petals. So this one's going to have 4 petals. And let's fill in pi over 2 and see what happens. 2 pi over 2 times pi over 2 is pi. So that didn't help any because that just gives me 0. So let's try another one. Let's try pi over 4. If I put in pi over 4, I get the sine of pi over 2. So pi over 4 gives me 5. You may have to slow down on that. But pi over 4 gives me 1, 2, 3, 4, 5. Cute flower. And you could try some other ones like 3 pi over 4. If you put in 3 pi over 4 right here times 2, you get 3 pi. Oh, wait, something's wrong. Oh, yeah, I'm sorry. If I put in 3 pi over 4 times 2, you get 3 pi over 2. You'll eventually get -5. You're pointing this way, but it's telling you to go back 5 units. So I'll walk back on this pi over 4 line. 1, 2, 3, 4, 5. So I've probably given you a lot to practice. Let's do one more. That's a flower because of this. It has 3 petals. If it's odd, it has the number of petals. If it's even, it has twice. The petals are going to be 3 units long somewhere. So let's make them 3 units long first, and then we'll figure it out. It'd probably be like this if it was cosine. I expect this one to be tilted. So let's kind of fish around for a good number to fill in. Let's try 30 degrees, since there's 90 divided by 3 is 30. So I'm going to put in pi over 6. So I'm thinking right here, I'm pointing toward pi over 6. Okay. If I said multiply 3 times pi over 6, I get pi over 2. And so if you wrote all that down, you write pi over 6, comma. Then you fill it in, you'll end up getting -3. So at pi over 6, I'm going to have to back out -3. 1, 2, 3. And that should be it. So anyway, you can just keep practicing until you feel like you've got it, and tomorrow you'll need to get 5 right.